Hello, it's a pleasure to be here with you all, although I'm not quite sure how I feel about following up George Bina's presentation. My name is Cuellar. I am from Design Science. I'm a product manager there, and at Design Science, we make math typesetting software. To give you an overview of this presentation, we're going to start with a brief history of the MathML standard. Then we'll go into MathML's adoption into other standards. We'll take a look at where MathML software support is today, and then that'll take us to our conclusion. But before I reach our conclusion, as I mentioned yesterday, I do have a special announcement to make at some point during the presentation. But we'll just dive right into it. MathML, as many of you probably already know, is the W3C standard for encoding mathematical information in XML. In 1995-96, when HTML3 was in discussion, there was a general lamentation about the lack of support in HTML for mathematics. HTML, as you know, is the language behind the World Wide Web, which was built by scientists for scientists, and there was no way to communicate mathematical expressions except for with the use of images, even though math is at the heart of science. So this was considered a shortcoming of HTML, but the HTML working group faced two problems. One is that browser rendering technology was not at the stage yet where it could support the complex layout requirements of mathematics. And two was that to adequately support the requirements of the entire field of mathematics is a gigantic problem. There's just way too many requirements for the HTML working group to take into consideration. In fact, it was beyond the scope of HTML. So the W3C realized this was a problem, and they chartered the first math working group. The math working group also faced an immediate challenge. Mathematics are a largely symbolic language. So one symbol, here we have A cross B, could have several different meanings. This A cross B could be a simple multiplication of two variables, A and B. It could be the cross product of two vectors, or it could be the Cartesian product of ordered pairs. So even though we humans might be able to see at a glance what this A cross B means, the math working group realized that they would have to be explicit for computer interpretation of any math markup language. On the flip side, within mathematics, you can also use many notations to express the same meaning. Here we have three different ways of specifying multiplication. So not only did the math working group have to be unambiguous about the mathematics that it was encoding, but it also had to give people who wanted to publish their mathematical expressions complete control of the layout of the expression. The math working group solved this problem by splitting MathML up into three parts. There's content MathML, which gives the explicit meaning of the mathematical expression. Presentation MathML gives the intended layout of the expression, and then interface MathML allows you to specify both, to combine them as you need them. So this set a solid foundation for the MathML specification, and within 2 years, the math working group published the MathML 1 specification in 1998. However, as with any first version of a language, it's never perfect. So the math working group reconvened and followed up MathML 1 with the second version 5 years later. And with MathML 2, they've corrected some of the flaws that people had noticed in the first version. One of them is that MathML 1 didn't have any way to express a line break without the use of tables. And as it turns out, a lot of people want to use line breaks in their equations. So MathML 2 adds this, and then MathML 2 also favors cascading style sheets, which had grown more popular between 1998 and 2003 as a way of expressing style for their equations. MathML 3 became a recommendation in 2010, so it's just over 3 years old now. And with MathML 3, math has reached a new maturity. With this latest version of the specification, the math working group carefully considered the needs of various communities with a stake in communicating mathematics electronically. For the publishing community, they added new line wrapping and line breaking features, because though MathML 2 had added the line break, it just didn't go far enough. So with MathML 3, you can now specify maximum column widths and page widths so that an extremely long equation will automatically wrap to the next line. And then it also adds alignment features so that those second and third and fourth lines will align up to that first line. Here we're aligning by the equal sign. MathML 3 also adds elementary math notation for the education community. This was all possible in MathML 2, but you had to use tables to do it, which was an inelegant way of providing this notation, and it could be very tricky getting it to look the same between rendering engines. And then MathML 3 became a truly international standard by adding support for right-to-left languages and for notations that vary from region to region. Now, MathML was never intended to be a standalone language because mathematics are often used with some context. They're either parts of documents or parts of models. So to look at the success or failure of MathML, you really have to look at its adoption within other standards. For content MathML is ideally suited for scientific communities, and it has been adopted there for SLML and SBML. SBML is Systems Biology Markup Language. These are both biological modeling markup languages, and they both use content MathML. PhysML, as you might guess, is for physics, and PhysML also uses content MathML if MathML is involved. On the other hand, presentation MathML is used mostly within communities where you have to publish your mathematical expressions. DocBook, I think we all know what DocBook is. DITA is often used for help publication, help files, but can be used for other applications. The journal article tag set is used by scientific journal articles, or generally for that. The accessibility community has actually been pretty fervent in its adoption of presentation MathML. And the reason for this is that presentation MathML gives you the exact detail that is needed especially for assistive technology, to be able to get into that MathML to provide navigation and highlighting so that people with learning or vision disabilities will be able to comprehend the expression. That can be quite difficult if the mathematical expression is pretty complex. So this is why DAISY, which is used for digital talking books, NEMIS is a textbook standard, and PDF-UA is used for tagging PDF files for accessibility purposes. All of these standards also use presentation MathML, and they require it if you have math in your documents. But perhaps the biggest milestone for this STEM, technical and scientific communities is the adoption of within HTML5 and EPUB 3. The fact that HTML5 now supports MathML is a sign of just how far MathML has come. Math did not make the cut for HTML3, and as I mentioned, that's what prompted the development of MathML. It also did not make the cut for HTML4. At that time, math rendering technology had not advanced far enough, and browser vendors still felt that they could not adequately support the language. So now, with HTML5, we're finally getting to the point where STEM fields are adequately supported for digital communication of math. MathML's inclusion into HTML5 and EPUB 3 is especially significant because what it means in theory is that content producers can expect their mathematical equations to have consistent display between all devices on all displays. HTML5 and EPUB 3 have both been praised for their inclusion of different media types, and it allows us to take our digital content to the next level. And now this is true for the scientific community as well. with the inclusion of MathML. Now, we all know that computer languages are pretty much useless if you don't have the software to support them. So we'll take a quick look at where the software support is for MathML today. And the good news is that if you have to create MathML, it's now easier than ever. It's so easy that you can handwrite your mathematical expressions and convert them to MathML. And that's possible with tools such as the Math Input Panel, which now ships with Microsoft Windows as of version 7. Mobo Math supports older versions of Microsoft and the Mac operating system. And then Vision Objects creates a tool called MyScript, which is a web application for handwriting to MathML conversion. If you have to work with computer algebra systems, you can use Maple and Mathematica to produce MathML, and this is good if you have to take your models and then publish them, either with a journal article or a presentation. And Maple and Mathematica also support input of MathML. For document creation, some word processors and most XML editors now also allow you to create MathML, either with a built-in equation editor or with a plugin. Microsoft Word has its own equation editor. It has a proprietary version of MathML called it's OMML, which I always call OML. And, but they expect this to be converted to MathML. They even provide an OML to MathML style sheet within Microsoft Office that you can use. XML editors, Oxygen, FrameMaker, XML, Flare, all of these can produce MathML. For those applications that can't already edit MathML, there are a couple of software development kits available that enable you to add your math support, your equation support with MathML. My company, Design Science, makes MathFlow components, so I will unabashedly tell you that this is the best product out there for you. But we also, for certain situations, you can also use the Wirus suite as well. For rendering engines, MathJax is an open source JavaScript library. It's very popular for rendering your MathML on all modern browsers. That's, as I said, one of the most popular ones. MathFlow and JEuclid are other options if you have to convert your MathML to image files for inclusion within PDFs or other document formats. We've come a long way within the past 10 years with MathML support, but I've identified a couple of areas where some work is needed still. The first area is conversion from legacy formats. Proprietary math formats are especially difficult to get into MathML. If you have FrameMaker math in your documents or ArborText math, for example, you will either have to invest your own resources to develop the workflow to do that conversion, or you will need to hire conversion services companies such as Stilo or Data Conversion Laboratory. For LaTeX and Tech, you have several more options. Is LaTeX, somebody from LaTeX here? Does your software do MathML conversion? Yeah, okay. So you have LaTeX as an option. There are a number of open source packages that also do LaTeX and Tech to MathML conversion, but the problem with those is that they're generally not, they've either stalled as projects or they can be very difficult to get up and running. And so for that, it can be difficult. And then LaTeX also has a problem of a long tail of macros that often are not supported. For PDF documents, you're typically going to use some sort of OCR software to get your equations into MathML, to get your full document into an editable format like XML. But the only OCR software that advertises math support is the Infinity Reader. And that is not a 100% conversion, not a 100% success rate. So what happens is that you go through and convert all of your documents, and then you have to have somebody sit there and do a comparison of the source and the output to make sure that everything converted properly. The second area needing some work is with browsers and e-readers. HTML5 and EPUB 3 support of MathML is fairly recent, so the browsers and e-readers have not caught up yet. We do have the interim solution, which is MathJax. I already mentioned that. However, it is not the best long-term solution. And this brings me to the announcement I was going to make. I have a special guest here with us. Well, I will be bringing in a special guest. Frederick Wang started a crowdfunding project recently to improve both WebKit and Gecko's support of MathML. And I'm happy to announce that Design Science, in conjunction with XMLPrague, have made a contribution to his crowdfunding project. So he is going to join us to talk about what he's going to be doing. So let me just try to get him up here. Hopefully this will not have any problems. And while we are connecting, I just want to give you a brief introduction of, hi, can you hear me? Oh, hang on just a second. I just realized that I never turned my speaker on. Hi, are you able to hear me now?
Yeah, I can hear you.
Okay. Would you all mind giving a round of applause so that Fred knows that you're here?
Thank you.
So just to give a brief introduction of Frederick Wang, he is an independent developer who has dedicated a lot of time in improving math support on the web, especially. He's worked on the Mozilla and WebKit MathML projects. He's contributed to the MathJax project and also to MediaWiki Math. So Frederick, would you mind telling us a little bit about the status of math on the web?
Yeah, sure. So, as you probably know, only Gecko and WebKit browsers have some MathML support at the moment. But the problem is that the work has mainly been driven by volunteers so far, so it's hard to get some good quality. However, there have been two improvements recently. So one is that Wikipedia is finally going to switch to MathML support. So at the beginning, they will just use native MathML for Gecko browsers. And for the other browsers, until they get better MathML support, they will serve SVG, which is converted server-side from MathML. And another improvement is that many websites are now replacing images with so MathJax, and so they are now using MathML internally, even if they don't serve the output yet to the browsers or to accessibility tools.
Okay, so you've just mentioned MathJax. Since MathJax is used for rendering math on the web, how is that not sufficient as far as MathML, browser support of MathML?
So perhaps the most obvious issue with MathJax is that it is big and slow. And so, for example, MediaWiki developers were not willing to switch to the client-side MathJax output. And other issues with MathJax is that it requires JavaScript. So, for example, you cannot use it in a standard SVG document or in web feeds or in search results. And there are also many incompatibilities with CSS. So, in general, web developers are used to style sheets, but with MathJax, if you sometimes the CSS rules won't apply, or sometimes they will apply and conflict with MathJax's own rules. And there are issues with fonts too. So, for example, from JavaScript you cannot access some non-Unicode glyph, or you cannot have access to font metrics and all the font data. So it's not possible to get arbitrary support. Another thing that is different in MathJax is with web fonts. So in general, with web fonts, you get the rendering of the page, and when the web fonts arrives, the page is redisplayed. But with Majax, you'll have to wait that they arrive before you get the rendering. And finally, there is an issue with dynamic update of the page. So if you modify the MathML DOM with JavaScript, the page won't be updated. Or if you zoom in or if you rotate your tablet, the page won't be reflowed.
Okay, great. Now, can you tell us a little bit about your mathematics and eBooks project?
Sure. So it's a crowdfunding project. So the idea was to gather individuals and organizations with interest in MathML in order to fund development. So by the way, I'd like to thank everybody who contributed to this project. So I know there are some people in this room, so thank you. And I also like to thank Design Science and XMLPrague for their contribution and for letting me speak today about this project. So thank you again. So, about the technical aspect of the project, there are three aspects. So one is to improve WebKit support. So WebKit support at the moment is only basic. So the focus will be on fixing the main bugs. So in particular, the stretch operators. And in Gecko, the idea will be to implement the so-called math table, which has been introduced by Microsoft in order to get high quality. And finally, the last aspect is to write some example of scientific documents. So in particular in eBooks format. So this document will show interactivity with JavaScript, mixing MathML with CSS or SVG, or using Unicode, right to left interaction. And it will also mix with other HTML5 elements like Canvas, video, WebGL, etc.
Awesome. So I do know that others in this room have contributed to the Math and eBooks project. Can I get a show of hands if you have already? Thank you so much for your contribution to his project. We are looking forward to Frederick seeing what he comes up with. Now, if somebody were still interested in, or an organization were still interested in contributing, how would they go about doing so?
Yes, so I'm self-employed, so if people want, if some company want to contribute, they can just contact me and we can find an arrangement. And another thing that I'd like to mention is that other people are interested in MathML. So in particular, there is one Spanish consulting company which is working on WebKit development, and one of his engineer is really willing to work on MathML, so you can also contact this company. And I think Otan has some contact information at the end of their slides.
Great, thank you, Frederick. I will open it up to questions in just a second, but I did want to go ahead and show that page that you were mentioning. We do have information here on how to both keep up with Frederick's project, and also he had mentioned the Agalia project. The contact information is down here as well. So we are very much looking forward to hearing more about the Math and eBooks project. Hopefully it will improve the MathML support that we're already seeing on the web. That's just one area of improvement that we could still see within the MathML community, and we're looking forward to that. But now I will open it up to questions. We'll keep Fred on the line in case you have questions of him as well, Frederick. Thank you.
Thank you, Autumn. Thank you, Frederick. We have time for one or two questions.
Yeah, is the thing on? Okay, you're working on WebKit and Gecko. Google Chrome isn't using WebKit anymore. do you expect Chrome to fully drop MathML support in the near future? For
Frederick,
mobile performance, for example?
did you hear the question? I don't know if you want to take this one. He had asked if this is Robert, by the way, Robert Boersma. He had asked if we expect Chrome to drop MathML support completely now that they've moved away from
WebKit.
WebKit a little bit.
So, yeah, at the moment, I think Chrome developers are not willing to add the MathML support, but in theory, they are using Blink is based on WebKit, so we expect that if we reach good MathML support in WebKit, they will maybe change their mind and enable MathML support again in Chrome.
Now, the good news is that the scientific community is getting pretty riled up about the lack of support in MathML in Chrome, and so hopefully, you know, we've been pretty vocal about it. And if you have any interest in MathML on the web, please let the Chrome developers know how important it is to you to see them improve their support of MathML, or to add support at all, really. Any other questions?
Yeah. Any last question?
Okay. Excellent. Well, thank you very much for joining us, Frederick. And
Yes, thank you.
I'll let you